Happy Saturday, y'all. Back at it again. Um, Tonight's kind of a weird stream because I've been working since this afternoon on this one specific problem, and I will explain to you what's going on and what the plans are for it. But first, I would like to get back to reminding everyone about the showcase. So the Sega Saturn 31st Anniversary Homebrew Showcase is ongoing. I still need to update the website, so I will try to do that tomorrow evening. Unfortunately, I just didn't have time. I got distracted by today's issue, which we will go into. We have a whole panel of reviewers who will be helping to write entries into the zine to essentially review all the entries that are being put into the showcase. Deadline is May 11th. You can go to my website, emeraldnova.com, to look at all the information, all the details about entering your work into the showcases for Sega Saturn related works. So there's original games, translations, patches, etc., etc., even utilities. And there are 6 categories that will receive prize money. Again, this prize money pool is not currently accurate. There's actually a lot more in the prize pot right now, but I still need to update the website because it's all updated by hand. Thank you, Shane. EmeraldNova.com. Yeah. And the first thing you see when you go to the webpage is the link to the 31st anniversary. So, best original game, best translation patch, best non-translation patch, best utility, most creative entry, and most likely fan favorite entry are each going to receive 1/6 of the prize pool. Along with that, everyone who enters the showcase will be featured in the zine that we will be putting together with all of the reviews written by our wonderful judges and reviewers, etc., etc. I believe Cerbero still needs to be added to this list, but otherwise we still have Krista Lee, Dan Threx Shiro is joining, David Jimenez back again, Millennium Shane now as a judge, or sorry, reviewer, whichever you want to call it. I mean, kind of both. Pandemonium back again, Peter back again from the Shiro crew, and Trainoko again back to help out review these entries. We're hoping to put together a really nice zine. If there's interest and demand, I will do a printing run and sell them at cost or roughly cost plus shipping plus, some margin for error, because I tend to lose money on these competitions trying to ship everything out. Maybe not so far as Judge Dredd. But if you go, you see the entry form. It's a Google Doc, pretty simple, straightforward. I highly recommend you submit your entry as a resource on Sega Extreme itself to make hot linking much easier and to host it for other people. We already have people submitting entries to the competition. Rasputin has one. Looks like we have another one here from that one guy. There's always new people coming into the competition, so this might be your year. Again, May 14th. That is 5 weeks away. So, sorry, not May 4th, May 11th. So May 11th, over here, right? That's how many Mondays away? 2 plus 3, 4. So 6 Mondays away? Am I getting that right? 1, 2, 3, 4, 5, and this upcoming Monday. So yeah, 6 Mondays away from now. So, Yes, the PayPal link does go directly to the prize pool. All the money goes to the prize pool. I just haven't updated my website yet. I've been horrifically distracted. I am very sorry. Tomorrow evening, it will be up to date. Cerbero will be on the judges list. I will tally up last year's donated prize entries and all the new entries that entered through PayPal, and it will be reflected in the prize total. But I promise you, it is much more than $2.99, and I'm going to be upping my contribution to $3.99 to match the Saturn's relaunch price. Just so you know. Anyway, Derek has a new thing. Oh, people are actually submitting. This is nice. Is this Sakura 2? Oh, Sakura 2 is that? Okay, guys. You're up against Sakura 2. Get cracking. Sakura 2 got submitted to the showcase. Yeah, I'm thinking about what I want to do for the ads in the zine. I'm thinking like maybe some ads for like, the traditional Saturn accessory stuff, maybe some ads for some like homebrew stuff that's out now. I don't know. I don't know we can do a pack-in poster. That's a little... That's even... Whatever printing costs I would already have, that would just make it obscene. I'd be willing to do a centerfold. Not of myself, obviously, but of maybe some Saturn stuff, or maybe I'll just put Sakura. I'll find some... Let me try this. Sakura Wars... Sakura... not fan art, official art. See if I can get a decent picture of her. Eeny, meeny, miny. Jeez. There we go. We can do something like this as a centerfold. Yeah, that'd be a nice little fun callback. Anyway, showcase is ongoing. You got 6 Mondays, I believe I said, May 11th to submit. Plenty of time to get cracking, learn some stuff, and put together a nice little fun Saturn project. And if there's call for it, if people have demands for it, I will put together some SRL tutorials ahead of the competition, because the stuff I'm submitting is close enough to being done where I can grind out the hours last minute and do it on my own time without having to much about my stream schedule. On that note, I'm almost certainly not submitting Seniriu this year. Almost guarantee, because I've got 2 different projects I'm submitting besides Seniriu. But today is about Seniriu because I had finally figured out what I want to do for the height map formula, and that is what we're going to work on today. So, Shane, you keep there. I had, jeez, where was it? I forget the name of the software. I had a magazine editing software, an open source magazine editing software. It was somewhere on my desktop, and now it's moved somewhere else. It's not HXD, and it's not the Magic's editor, so I will go find it. But I have a freaking card games in my head. I have the magazine editing software. Anyway. Okay, what are we working on today? Oh, yeah, I would have deeply appreciated... So for those of you who don't know, Seven Shades and I joined Millennium Shane in hosting the Starcade, a charity arcade. We were raising money for Arnold Palmer Hospital for Children at MegaCon. So y'all missed us this last year. However, we also, Seven and I, hosted a panel about Saturn homebrew development. We got that recorded. Shane has generously, volunteered to edit that video, and it will be up whenever it's ready. And I'm hoping that Seven and I, and even Haas Machine, will be able to host a similar panel at PRGE this coming October. And once this video is edited and up, I will be discussing that with the PRGE folks to see if they're interested in something like that, and maybe even a little workshop. And I'll discuss more details about that as ideas get hammered out. Anyway, today's stream is about Seniriu and a height map exporter. So I kept telling myself and other people that, hey, I want to do this in Godot. Godot's a game engine. It makes sense to do in Godot. And then I kept looking at how I'd do the stuff in Godot, and I couldn't really figure out how I'd want to do it. And I just decided, hey, I already know Blender well enough. I might as well learn how to make a Blender plugin. And so that was this afternoon. And now I will show you what we have here. Oh, you know what? I should join in on stream chat in case anyone will pop in. If you're on the Emerald Nova Discord server, you can pop in and say hi. Well, I'm not sure how to spin blend as a verb into something relevant to this discussion, but I'm going to go ahead and say yes. Alright, anyway, what we have here is 1, 2, 3, 4, 5, 6, 7 by 7 squares, 8 by 8 vertices of essentially a height map. It's just a mesh grid. So what I did is I added a grid, and I made it, I believe right now it is spaced out 1 by 1. Let's check that out. 2.5. Global. Show me the global. Decent global. Yeah. So it's spaced by 1 by 1, right? And with that said, let's go over to the Python code. I'll zoom in a little bit for your guys' benefit, and see what's going on over here. This is not a super complicated Blender plugin, and I'm still kind of working on it because the export's not done yet. And there's a few Saturn peculiarities that still need to be worked out. Anyway, I've got two classes here, a height map and a height map exporter. We'll get to the height map exporter later, but essentially it's just a container class for just working with Blender, so I can use Blender, as a use Blender natively. Just add a little option. So here, I'll wipe it and you guys can see the outside. 7, you're free to join me in chat if you like. Anyway, so let's start from the top. Okay, we do our necessary imports. I need a regex for scanning strings. I need math to do math. I need a counter to help me create the histogram that helps me efficiently generate the height map information based off of just vertex data. And I need the operating system to write files. Let's go down all these functions at the same time. The necessary information to express a height map are the numbers of vertices in each direction. So there's xnum, ynum. There is the number of textures that I plan on having, and I am working my way up to exporting the textures alongside the height map inside of the file format, so I can just import or load one file as a binary and just do the necessary data transports. And it is 4-byte aligned. I want to drop my music by 20%. Okay, let's open up voice meter real quick, and here. Oh, okay, that was the opposite of 20%. Let's try minus 18. That's 2 decibels might be a little bit extreme. Minus 17. Anyway, so these are the numbers of x coordinates on the height map, y coordinates on the height map, and texture numbers. So x and y coordinates, you're essentially, the height map, you're kind of guaranteeing yourself that you have a rectangle, if not a square. In this case, it's a square, but we can do rectangles too, because it's handled. Texture number is how many textures. In this case, textures that we're calling them are actually going to be materials in Blender. That's how we're going to be looking them up and retrieving them. So I have 8 textures here, so that's going to be the texture count. X size and Y size. So in Blender units, we're going to have the distance between any two height map items. So there's open up that thing. So we start with 0, 1, 2. Okay, so the X position size is 1 Blender unit. 1, 2, and here's 7. Sorry, 7 shades. I was counting. I didn't want to throw you guys off. Welcome to the stream, 7 shades. Okay. Size of the grid. 7, am I not hearing you, or are you just being quiet? Because I just want to double check my audio is correct. I don't see you glowing, so either it's a microphone issue, a Discord issue, or something like that. But I'll wait for you to figure that out. Anyway, vertices. These are going to be the heights of each vertex along the z-axis in Blender, which will get transformed into minus y-axis in the Saturn. And these are also going to be essentially the Blender units. So this one here is like 3 meters tall. We're going to convert that into a Saturn's fixed point. So that's going to be a 32-bit number in which the top 16 bits are the integer portion, and the bottom 16 bits are the decimal portion. Yeah, 7. I don't see you glowing, so I think it's your mic. Okay. That is the vertex. So each one of these vertices, it's 1 per little dot here. So it's going to be, if I have 7x7 quads, it's going to be 8x8. So basically n plus 1 times n plus 1, and they're all going to be 32-bit integers. The quads themselves are just the texture index, and there's a lot fewer of those. So actually, I can address these as 8-bit integers. So
can you hear me?
Oh, there he is. Here's 7. 7 got a head start on me on doing Blender stuff. I can hear you. Can you hear me? I think you can't hear me. I think you solved one audio issue, but you have 1 remaining.
Hear me?
Yeah, Can I not be heard? Is it me? Is it me who's wrong? I see my volume is non-trivial on Blend or on Discord. Looks right. Well, yeah, you guys hear both. I think Seven can't hear me on the Discord end. Anyway, so I was talking about the quads are the texture indices. So these are just going to be 8-bit integers for each. So now we have n by n times a byte each. And then the textures themselves, these are going to be sizable. So this is RGB 15 data. I haven't handled this yet, and I'm going to get around to it. Probably not in this stream, but eventually. So each one of these squares is probably going to be either 16 by 16 or 32 by 32 sprite, or a texture of some kind. And so we need to store 2 bytes per pixel. So let's just call it, let's say we have a 32 by 32 times 2 bytes. So each texture would be 2 kilobytes plus another 2 kilobytes, because we want to also be able to do live subdivision. So when we get closer to a quad, we want to be able to chop it up into quarters to be able to do multiple draw calls to help with the warping issue on the Saturn. So realistically, a single texture could be...
Testing. Can you hear me?
I can still hear you, even though you're coming in a little choppy, but I don't think you can hear me.
I can hear you now.
Okay, good.
Okay.
All right. You're coming in choppy. I'm gonna drop the music just a hair, because you are coming in kind of quiet. And by a hair, I mean -21. All right. So essentially, pretty much the entire file format is probably going to end up being like texture data, because every texture is probably going to end up taking 4 kilobytes of data to account for the subdivision. And so if we look at it like what's the next biggest thing is probably going to be the verts, and the verts is, let's call it like 8 times 8 times 4 bytes per vert, 256 bytes compared to 4 kilobytes per texture. So pretty much the entire file format is going to be texture data. But that's fine, because video games are a visual format and you have to have text. And we have half a meg of VRAM to shove them in, so we could probably afford 512 divided by 4. We could probably afford like a dozen or well, let's say we fill it up half with height map textures. 64, that's probably too much. Like 32, like a quarter. Take up a quarter of VRAM and fill it with height map textures. That'd be great. Anyway, so let's go through and see how this thing works. We're essentially, we go to our container function. When we execute that command, we are going to grab the context of the scene. Seven, do you have a dog outside? Okay, I'm going to take that as a yes. When we execute the command, this script, it's going to grab the scene from context. So there's a scene collection, essentially everything in the context of Blender for our purposes. And it's going to search for an object by the name of exclamation HM. And so that is this object right here. So the height map must be named exclamation HM. It's going to assign that object reference to this variable, which will then be used to generate, well, not generate, we're going to make a height map class object, and then we're going to use that object to generate or calculate height map itself. So then let's go over to the calculate function. Calculate will assign that object reference to itself and then start running different calculations. So let's go over to map size. Map size. Oh, I still guarded this. That's probably not necessary, but okay. I should probably move this guard over here. There. So if for some reason the object that gets passed is essentially a null pointer, we will terminate without trying to do any of these calculations. Otherwise, we'll give it our best go. So the map size will start counting for unique instances of X and Y values for all these vertices. So it's pretty important that all these vertices remain aligned to this grid. So if you start moving them left and right, you're going to screw up the whole thing. We will then go through every vertex in the object data. So the object in this case is this mesh right here, this guy. And so it's going to go through every vertex inside of this object, and we're getting the global coordinates for it. So that's why this matrix multiplication is here. Really weird thing here. I guess I haven't done Python in a while, but the matrix multiplied by vector is done with the @ symbol as opposed to the asterisk, which would just be element-wise multiplication. We have the world rotation matrix applied to the local coordinates of the vertex table to generate, well, an element of the vertex table to generate the vertex expressed in the global variables, or in global coordinates. We will then convert it to a tuple, so that we can just read off the indices. So 0 is x, 1 is y, z is 2, and we'll see that later. And every time we find a unique instance, we take the expression of that, that coordinate down to 5 decimal places. So rounded to 5 decimal places, which is basically the precision of a fixed point variable when we express it as a decimal. And we add 1 to that count. And essentially we're building a histogram. And the histogram should be, all the unique values should have the same value, but the point is we will have all of those, the actual values themselves, the x and y coordinates accounted for. So x count is keeping track of all the x coordinates. Y count is keeping track of all the y coordinates. We will then sort the items by the keys. The keys in this case being, like all the x and y values that we found when we were iterating through all the vertices. We will grab those x and y values, which are the keys, because this is essentially a hash table, if you want to think of it that way. And then we will take the... Why is this mine? Oh, okay. So the number... Okay, x sorted first key is essentially saying, hey, sorted itself is the counter that tells you how many times it counted that value. So the first value is like x equals 0. How many times did it count x equals 0? It counted it like 8 times. So we will grab the number 8, subtract 1, and then that will be the number of squares in this height map. So once again, if we have 1, 2, 3, 4, 5, 6, 7 on each side, there's going to be 8 vertices on each side. So it's counting the number of unique vertices or unique x entries in that vertices. So in this case, it has an 8 count of x equals 0. We subtract 1 from that, we get 7, which reflects the count of squares along that dimension and squares along that dimension. And that's the x num and y num counter there. And then we get the size of them, which is essentially just saying, okay, take the x coordinate here, subtract it from the x coordinate here. That's what this means. And then we want it in fixed point coordinates, so we multiply through by 6, 5, 5, 36, which is 2 to the 16. Sorry, wait. Yeah, 2 to the 16. And that just puts it in the fixed basis. And that's x size. That's how we get the first bit of that. Map textures. We go through map textures, and again, we're kind of playing a little bit with the Blender API here. Fun little bit of trivia, because this was like an hour of my day. There's multiple ways to generate a list of lists, essentially a 2D list, what you would conceive of as a 2D array in Blender. However, if you don't do it this way, and you do it the way you often see online, which is like 0 times x number times y number, you will end up with an array of references to the same array over and over and over again. Oh, thanks for the follow, Irish John Games. I hope you didn't catch me in the middle of this, because this is all getting kind of we're getting in the weeds on this one. But thank you for the follow, and glad to have you here. Anyway, so In fact, what I'll do is I'll just Google real quick. Because, like, hey, Python 2D list declaration. I want to see if I can find the wrong way. Okay. See, this is a nice little shortcut to make a 1D array. And this is great. Now, you can do this twice over. You can do this, right? What this will do, it'll give you this array, but actually every one of these entries here, here, and here, these are degenerate references to themselves. These are all copies of each other. So when you go and you write through this, 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 you get to the end, you start writing these entries. The first, you write this entry right here, you're writing this one too, and this one, and this one, and this one. It's insane how they made the shorthand for Python to do it this way, because that means, you know, it's some weird way of preserving the pass by reference, but you don't expect it to work that way, and you end up just overriding all the work that you did at the end of the loop. So that is why we are writing it like this. We are iterating through and writing each individual entry as a 0, and then we're going through again and iterating through in a for loop. So we have two, kind of like an inline double for loop, but this makes sure that it gets implemented for every entry in that 2D list. Make sure that, you know, every individual entry does not have a reference to another entry. Anyway, that was a significant portion of my day trying to figure out what went wrong. Moving on. Okay, going back to actually talking to the Blender API, now we want to take the object that we have found, go into its data, get the vertices. We're going through all the vertices again. And once again, we're grabbing the vertex data. This is local coordinates, v.co. And we multiply through by the world matrix, rotation matrix, to get the global coordinate. We then convert it to a tuple so we can start addressing it. And let's see. We have the coordinate itself times 65536 against times 2 to the 16 to bring to fixed coordinate space, or fixed coordinate basis. Because x size is already in fixed coordinate basis, we are dividing out x size by you know, that coordinate to essentially get the index, and we round down, you know, or we round to the nearest one, because there's always going to be some floating point nonsense going on. So what that looks like is over here, right? We have let me just grab it at random. Let's grab this guy. I want to find the x coordinate for this guy. It's 3. We have 3. That's 3 in floating point basis. We're going to shift it into fixed point basis by multiply through by 2 to the 16. X size itself is going to be 1 times 2 to the 16 minus 0 times 2 to the 16, so 2 to the 16. So we multiply through by 2 to the 16, divide by 3 by 2 to the 16, and we get our x dex, which is just, for this guy, 3. So we have 0, 1, 2, 3. That's the correct one. And the same thing happens for y. We're going to get 4. So 0, 1, 2, 3, 4. And now we have that vert there. And now we're going to retrieve the z value, which is coordinate 2. Again, back into the fixed point basis, because that's how we want to store it for the Saturn. So multiply by 2 to the 16. And then we... Wait. You go in here. Yeah. Take the coordinate, multiply by 2 to the 16. That'll preserve the decimal portion of it, and then we floor it to get it into fixed point basis. Yeah, that's correct. Okay. Little bug there that I caught. Oh, no, I was correct the first time. I knew what I was doing when I was doing this. Okay. We only want the whole number portion of it. So we take, we round down the coordinate. So if it's like, let's say, for instance, we had 3.5. It gets rounded down to 3. We multiply through by 2 to the 16. That gives you the 3 part. That's the whole number part. Then we go to the decimal part. We subtract out the whole number part, and that gives us, essentially, let's call it like 3.5 minus 3, but in fixed point basis. So that's 3.5 times 2 to the 16 minus 3 times 2 to the 16, giving us half of 2 to the 16. For those interested, 2 to the 15th. And that is what gets stored as a decimal portion of it. And so this number is going to be strictly less than 2 to the 16. This number is going to be at least 2 to the 16. multiples of 2 to the 16 actually. And so this gives us the big half and the small half of our fixed point. We add them together to get a presumably 4-byte number. And then I just print it out here as a little check for myself. That is the map height routine. Okay. Wait, did I skip? Oh. Let's go back and do textures. Okay, I forgot the textures part. They're running in a different order in my calculate than when I defined. I did it now. Okay. Textures. We need to iterate through quads. Again, we loop through everything in 2D space to initialize our quads. This time, instead of having xnum plus 1, because xnum is the number of faces that we have, or the number of quads that we're going to have, xnum plus 1 for the vertices, xnum for the quads. So there's n times n, or n plus 1 times n plus 1 vertices, n times n quads. And we start with an assumed 0 textures. So we go in, we get the polygons out of the object data, and we're iterating through all the polygons. And I'm referencing this F for face because I thought they were going to be faces, but they're called polygons in the API. Oh boy, let's stretch this out a little bit. Okay, so it's a little bit messy, but I'll try to explain as best as I can. This is why we need to bring in the regex. We have the material slots for the object. The polygon itself has a material index associated to it. It's assigned to it over here. So when I, let's go into face mode. When I select like HM05, that face or that polygon is assigned to that one material. So the material is associated with, or sorry, the face is associated with material, or the polygon is associated with the material. So we grab it from this material index. We use that material index to go into the object and find the material slots, and that material index indicates one of the materials available to that object. Drill down into the material itself, and then its name, and that gives us the material name. Material name is HM05. I want to use that as the index itself. I don't want the letters, I just want the numbers. So we do some regular expressions. I don't know why I said reg edit. Regular expressions to grab the number part out of the full name. So don't ask me how to explain regular expressions live because I'll never be able to do it properly, but essentially this string indicates grabbing D, the number, out of the string and removing everything else. So HM05 becomes 05, which gets parsed as the number 5, so it's just 5. That gets stored as a regex, as a search return, or regular expressions search return. There should only be one entry there, so I'm just going to grab the first entry I find, index 0, turn it into an int. Now there's, in this case, 5 stored in matrix dex. And now I set up xdex and ydex as a ridiculously high number that should never be true. And then I say, okay, the number of textures is the maximum between what I currently have as the number of textures and the matrix or the material index that I just found. So in the case where I have assumed 0, if I find a material index 0, I know I'm still in the first one, so I keep the 0. If I found, in this case, index 5, I know that whatever is here, if it's less than 5, I have at least 5, so I overwrite it with 5. And that's how I keep track of the number of textures. You see at the end we add 1 to it because 0 indicates we have at least one texture, index 0. So we're tracking the highest index here, we add 1 to track the actual count at the end. Looping through the vertices of the polygon that we found, we go through and we find the x index and the y index of each of the vertices. Every polygon is going to be, in our case, associated with 4 vertices, but the way I wrote it, it could be an arbitrary number of vertices. What it's going to do, it's going to find the most leftmost x-coordinate and the most bottommost y-coordinate. So in this case, it's going to be 0, 1, 2, 2, 2 over here. And it's going to save that as xdex is 2, ydex is 2. That's what the minimizing function there does. And again, we have the coordinate in fixed basis divided by the size, which is already in fixed basis, rounded down to get us our integer index of that vertex coordinate. And we're saying that the way we are addressing this height map is it's indexed to its bottom left vertex. So in this case, the bottom left is at 0, 0. That is also face 0, 0. The bottom left here is 1, 1. That face is 1, 1. In this case, the bottom left is 2, 1. This is face index 2, 1. Well, here is 2, 2, face index 2, 2. So then in the quads, we get 2, 2. We write in the matrix or the material index there. So in this case, HMO5 is going to be index 5. And so that we know when we get to the Saturn to draw things out, we want to grab the 5th texture in the texture pack that is loaded associated with the rest of this height map file. Okay. And then I print things out just to... what's left in the routine? We got the height. We got the textures. I already explained the height. We write to file. This is still a work in progress, but essentially, one of the fun things about the Saturn is it's big endian, and on a modern computer, we're all kind of used to little endian data expressions. So we will write out, the file, and then I'll show you why that's a big deal. But essentially, what we're going through, we're finding the directory we're currently in for this Blender file. I'm going down and making a height map subdirectory if it does not already exist. That's what this does. If it's okay, or if it exists, then things are okay. Then we just move on. If not, we just make it. The file path, we add in the map.shm, that's Seniriu height map file. And then we just print out the file path just for logging purposes to monitor what's going on. And then we open up the file for writing. WB indicates write binary information. So we're going to be writing basically bytes, like explicit bytes. So the first thing we're going to do is we're going to write a whole bunch of uint8s, so single byte information in order. First one is the number of x coordinates. So we're saying there's going to be a maximum of 256 or 255 bases on the height map, meaning a maximum of 256 vertices. I probably could do that, 7. However, this is what I ended up doing this afternoon. I mean, so Raimi was helping me earlier with this, or at least, rubber ducking for me while I was doing this on the screen share, and he just hates Python. He just does not like how squishy and soft it is, I guess you should call it, or something like that, or the white space determinism that it has. So it ended up with me trying to figure out different ways of expressing lists and individual data as big endian bytes. So anyway, I'll move through this and I'll explain why the big endian is important here. Oh yeah, sure. If you want to drop it in the height map thread, I'll go check it out. So anyway, we go through and we have this. I believe this is an array, not a list, but I could be misremembering how Python works. Add some white space for readability. Where we write in X number. This again going to be 8-bit, so up to 255. Y number. Again, up to 255. So there's the number of faces in the X direction, number of faces in the Y direction. Number of textures, again, we're limiting to 255. And then just we're adding in a 0 there. We just want some black space so that we can align our file format to 4 bytes. The Saturn prefers 4-byte aligned, if I recall correctly. I believe that was the conclusion of my discussion with Ray, but I could be remembering that wrong. But essentially, I'm making sure my file is 4-byte aligned. We pack in that data as a byte stream, rewrite the data, and now that's the first thing in the file. Let's see. Again, okay, I should mention, though, that when you open your file with W for a write, you are pretty much necessarily wiping it out and starting from scratch. So this is not an iterative write or an additional logging or something like that. This is overwriting and starting fresh. Anyway, grid size. These are fixed expressions, so 4-byte expressions. So what we end up doing is we take that number itself, run the function 2 bytes on that number, say that it's 4 bytes big. So essentially we're saying, hey, this number, express it as 4 bytes, but put it as big endian. We're doing that to the x size and the y size. And again, the x size is the distance between 2 points in the x direction, y size is the distance between in the y direction. That is what I have so far. So the way that this works, and I'll explain the Blender nonsense to you now just real quick. We have some boilerplate up here to tell you, hey, this is what the plugin is supposed to do. This is the version of Blender that we're expecting, 5.1.0 here. And this is supposed to operate on an object. And then down here, we're saying, hey, on the object menu, append this menu function that executes essentially this execute command. This execute command creates a height map object and then runs the calculate function on the height map object. And the calculate function includes the write to file command up here. This script's main function is only there to register this plugin into Blender. Now, that's essentially how these plugins work. You're meant to have these things load on Blender startup. When you're developing this thing, at least based off of the quick start guide that I read from Blender themselves. Oh, thanks, John. Again, this was like a few hours this afternoon. I came back from like a 6-mile hike in the desert, and I was like, okay, I finally have an idea for how I want to do this. Let's get this done while I have the Saturday ahead of me. Because, you know, Lord knows I'm not going to have the energy or wherewithal to do this on a Tuesday night. Oh, geez, who's wait. Oh, we got a raid! Haru! I recognize your name, but I don't know your SX name, but thank you for the raid. You guys unfortunately just missed the entire explanation of how the Blender plugin structure worked. But I am about to demonstrate how it operates. So, we're still yeah. Anyway, let me start from the top about the Blender. Blender boilerplate, name of the plugin, Blender version, what it's operating on, an object. We go down here. We have a class whose only job it is to say, hey, I'm operating on something. And then I have some boilerplate Blender plugin stuff, so Blender knows how to handle me. And I have an execute function that takes the current context and does the thing that I want to do, which is set up my separate class object that I defined up here, the height map, assign an object to it, essentially, and then calculate based off of that object. And that calculation goes through everything we need and then writes the file. And then it says, hey, I'm finished, because Blender needs that to happen in order for it to know that it's not crashing out. And it's going to crash either way because it's freaking Blender. But, at least we're doing what we're supposed to do, and Blender can screw up on its own time. Menu function says, hey, take the height map export class, take that ID name, and that is the menu function. And it already knows it's going to execute the execute function. When we register the function, we're going to register the plugin itself, but then we're going to add the menu function to the object menu, right? I'm not sure that the unregistered function actually does anything, because I'll show you in a bit. When you're developing the Blender plugin, it's a little bit different than when you're using it. When you're using it, you put in your startup, and when Blender starts up, you have your plugin ready to go. When you're developing it, you're constantly saying, okay, let us save the file. That's mine EU, right? And then we're going to run this run script. And all this run script does, here, let me have that over here. You're going to press run. And what just happened is registering operator class height map export has been okay, well, I mean, forget about that part. We have registered the plugin. So now when I go over to, I select this object, or go to the object, and then here, down here, I have added export height map as a plugin feature. So at the bottom of the object menu is my Blender script. I click on it, right? And now my script has run. So let's go to the top of the script and see what's going on. Again, I have a 7x7 face array with 8x8 vertices. And so the first thing you're doing is we're going through and we're figuring out, let me take away this. Yep, and we'll go into face. There we go. And we'll figure out what this means this way. So I'm going through in order, and I'm saying, okay, first let's go through the faces and identify all the textures. Appears what happens. So the bottom of this is all HM00, so I'm getting the entire bottom row zeros. Or is that the entire column? Sorry, the entire first column is zeros. And then I go through, and I say, okay, let's go through the entire second column. Okay, that's this here. Jeez. That's 0, HM1 is green. Okay, I gotta stop clicking. 0, 1, 1, 1, 1, 1, 0. Okay. Third column, index 2. Here. Okay. We go 0, HM1, and then HM5. Right? That's the black one. And then blue is 3. Wait. 6. Am I going in the wrong order? Oh, I've reversed these. Oh, I gotta swap these indices. Okay. So what we're doing is we're actually going from here to here. We're going 0, 1, 5. This is why I put this pattern up here, so I can catch this kind of stuff. 6, 7, 1, 0. Okay. So we have the first index is telling us 0, 1. Oh no, this is correct. I keep doubting myself, but I did it correct the first time. We have the first coordinate is the x-coordinate. X, 0, 1, 2, 3, 4, 5, 6. All on y equals 2. So, okay, no, this is working great. I'm surprised I didn't screw that up. Okay, moving on. Index 3. All right. 0, 1. Blue is 3. 3. White is, or gray. No, white. Yeah, white. White is 4. 1, 0. Okay. Row 4. 0, 1, 2, 2, 2, 1, 0. Okay. And then 5 is 0, a bunch of 1s and 0. And then last one is all zeros. Okay, so the texture indexing is grabbing the correct textures in the correct order, and it's saving that as the quad Lobster Fest. Okay, Night of Dragon. Normally, I take what you say as a troll, but I am... You've got me to successfully check this on. Not sponsored content. I actually just have terrible taste, and I have high blood pressure, so I can't really, I can't do a lot of salt, but I'm willing to let myself suffer for an event like this. 1.25 pounds. Oh, just one, though. Lobster Fest, to me, tells me that there's, like a lot of, like endless shrimp. Like, that's what when I hear Lobster Fest, I think endless shrimp. No way. Out of curiosity. What looks the best here? Eeny, meeny, miny, you. I like how you look. Right? Let's see what's in Berkey. I think we have like one. Alright, let's I just want to see how much this is. Butter, cheese, okay, just Ipsis. Okay, starry. Okay, how much? $45? No. Okay, you got me excited for nothing. Nope, that was a waste of my time. Shame on you, Knight. Okay, back to Blender. $45. You know what? I can go to the Asian market, grab myself a lobster for like 20 or 30 bucks and just do it myself, and I can just kill myself with butter on my own time. I gotta pay someone to kill me butter and salt. All right. Let's move on to the vertices. Okay, let's go over here. No. That doesn't really help explain the point too much better, but at least you can see the points. If that was a pun, I didn't mean to do it, but I claim it anyway. really should have orthographic view, but I don't want to press that button. I don't remember where it is. Anyway, okay. We're going to go through and we're going to look at... Oh, you know what? This makes it easier to look at. All right. So, we're going to go through, and now we're going from 0 to 7 because, again, 7 faces, 8 vertices on each side. The edges here I have all set to 0. So, essentially, all these numbers should be the height of the z value of all of these vertices. So, 0, 0, 0, 0, 0, 8 times. First row that's interesting is index 1. Now we have, these guys are set to height of 1. So let me just, there we go. Z value 1 over here, Z value 0. Didn't lie to you. Z value 1. Now, 1, again, we're going to the fixed point basis. So we have to multiply through by 65536. And so we have a 0, and then 1, 1, 1, 1, 1, and then 0, and then that gets converted fixed point basis. So that's what these values are. Moving on, row 2. All right, here's the fun part. This is 1, and then 3, and then 3, and then 3, and then 2.5. Okay, so that's 1, 3, so that's 25536 times 3, 3, 3. This is 25536 times 2.5, and then 1 again, and then 0. And I'm just gonna have you guys trust me that this continues the pattern of me being correct all the way down until we get to row 7, where it goes back to 0 again. Okay, over here. All right. And so the export for the height appears to be correct. And again, we're exporting on the fixed point basis, so each one of these numbers is representing a 4-byte expression of the that height. So down to essentially 5 decimal points of precision. So okay, actually, let me cover that too, because this is in the guide. So preferences. If you go to interface, so you got a couple things you want to turn on. You want to turn on Python tooltips and developer extras, and that just gives you all the. And let me just flash screen so. Oh no, I use it. I can stay. You want developer extras and Python tooltips under the preferences, and that'll just get you Python. And then what you just end up doing is, you know how you just drag from the corner to create a new window? Like, I don't want to do it because I don't know how to get rid of it. But essentially, you take the corner, you click, and then you drag it out to create a new window. And then you go over to the text editor. And then you get your Python view. So that's where I'm at. The funny thing is, you have a Python console in Blender, but as you can see, it's completely blank because when I run the script over here, right? Remember, I got object export height map. When I run the script over here, nothing happens in this Python console because this is literally just, hey, wouldn't it be nice for you to just run one-line Python on your own time? This has nothing to do with what's going on here. You can just do Python on your own. This is literally equivalent to just opening a Python terminal. There's no reason for this to be here other than for me to have a space to put this, which is, here, let me close this and I'll open it back. Oh, I don't think I can close it. This is tied to the actual Blender. Anyway, if you actually want to see the terminal output of the Blender script that you're running, you go over to system, geez, where? It wasn't here, was it? Reload scripts? No. Here, was it here? Oh, geez, I've been doing this all day. Why don't I know this anymore? Window? Window, toggle system console. See, now it's gone. All right, so I'll go window, toggle system console, and it's back. Okay, so window, toggle system console, this gives you the console output that you need to actually monitor your script. So like this is always on for me now. Okay. So now that we're done, we got our texture indices, we got our heights. We have the location in which I want to save my Seniriu height map file over here. And again, actually, let me show you guys. Right? We'll run this again. In fact, I will delete the height map. Gone. Right? So, object, export height map. Uh-oh. Blender. I told you guys, Blender's just gonna crash no matter what. Like you can't avoid it. It just happens. Blender, no! Blender, no, I don't want to go back to Lobster Fest. Oh, jeez. Okay. Let's open up Blender again. Good thing I kept the splash screen. Height map. Okay, let's try again. And... okay. It's gone because I need to rerun the script. But let me make sure that I'm running the latest version of the script, because Blender has this weird thing where it'll just keep crap in memory for no good reason. So I'm reopening my script by closing out, unlinking, essentially, closing out what I had before, and opening the file that I already had saved, that I know works, because it's just working right now. Running the script, again, only runs the main function here, whose only job it is to register the plugin into the place where I put it, which is the object menu. So run, object, there, export height map is back. And once again, I wanted to show you guys this. There is no height map subdirectory here. Oop. There it is, height map. And there is my Seniriu height map file. So now I get to go over to HXD. Hey, no spoilers. Okay, we'll drag the file into HXD. All right, so the first thing we're going to do is go over the first few numbers. And as you may recall, I wrote this down off to the side of the screen so I can recall. First one, the first number we have is the number of columns. That is equivalent to the X number. The second one is the number of rows. That's equivalent to the Y number. And this is the number of faces, not the number of vertices. Number of vertices, 1 plus this. Well, this is why I do these streams tonight. I'm going to obviously be uploading this to my channel, and this is probably going to be more useful to Blender folks out in the wild and Saturn developers specifically. But I'm hoping that this height map tool, once I get it in the Saturn and working, which is probably not going to happen tonight because it's already 1 hour in and I feel myself crashing. But I'm glad I got to go through this explanation of how to get Blender tools just running. Anyway, 8. What was 8? 8 is a number of textures. So I had HM0 through HM7 over here on this object. That's 8 total. So that was, I took HM7 was the highest addressable and I added 1 to that. Now that necessarily means that when I go back and I want to make a new height map, I have to number them in an order. I can't skip any numbers, otherwise I'm going to have an off by however many I skipped error when I try to do stuff. And the number of textures is not going to line up to the correct indices. They have to be lined up in order. Okay. Eeny, meeny, miny, where was I? HXD. Okay. And then 0, like I said, little blank dummy bit. I was just adding some space here because I want to be 4 by the line because the Saturn is cool like that. Now, here's a little flag down here called byte order. We are used to little endian byte order. So that is, kind of the numbers going in order. So if I go over to little endian and I examine this, I have the number 256. Okay, sorry. Yeah, so that's essentially just let me make sense of this. Oh yeah. Okay, no, sorry. This is reverse order from what we're expecting. Okay, so yeah, that is correct. So essentially, what we're saying is here's the bottom part of the number. Here's the top part of the number. We're treating it as a 2-byte number. And so if you think about this in binary terms, Notepad, where are you? Sorry, guys, you're getting flashbang today. If you think about this in binary terms, we're going to have, I'm going to space it out in 4s. 1, 2, 3, 4. Or 1, 2, 3, 4. And then 1, 2, 3, 4, underscore, 1, 2, 3, 1. Okay. Now I'm so... What is this? You know what? I think this might be incorrect. Oh, no. Wait. No. Okay. I got confused because I was only grabbing 2 of them. I should have been grabbing 4. Here's what's going on. Recall that the fixed point data structure is, well, I mean, it's not data structure, basically a SN32. It is a 4-byte integer that we're using the top half of to express whole numbers and the bottom half of to, yes, it is 1616. So So the big endian version of it is human readable. We're going from big to small. I had a flashback to Rugrats there in my head for a second. And so when we think of it as a 32-bit integer, this 0, 1, 0, 0, 1, 0, 0. The first two are the whole number bar. It's basically it's just 1. And the last bit is just the blah, 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 decimal part or whatever, which is currently 0. And we can play with the object to show what it's like when we actually resize this thing a little bit after this. So big endian, we're going from big to small. And so 0, 1, that's expressing the 1, 0, 0. And so if you just look at this, this is essentially 2 to the 16. That is 65536. And that is a correct interpretation of what I wanted to put here, which is the size in fixed of one spacing between 1x to the next. 65536. If I go to little endian, which is like the default way that you would end up writing this byte stream when you start writing naively, it looks like 256. Why is that? Because we're going little to big, so you start writing from right to left, right? So instead of this, you end up getting something that looks like this. Again, sorry for the flashbang, but I didn't feel like opening Notepad++. And so what it looks like is 0 and then 0, and then we have 2 to the 8 with the 8 bits of 0 padding there. So what I wrote here in big endian is the correct interpretation. That is 1 in fixed. 256 is a transposing of what we just did. And the Saturn is going to want to read in big endian. So that's what we wrote for it. Again, over here, we have the same thing, which is a scale of 1. So let's play a little fun game, and let's scale this thing. So scale on X, someone give me some number in chat. Not going to wait forever, though. I'm going to say 1.5, you guys can give me the Y scale. 1.5. There we go. And then, how much do I have to ship this by? 4.25? Shoot, no, that was wrong. No, 5.2. 5.25. Really? No one's going to give me a number? Fine, I see how it is. Okay, that's right. Scale along Y by 0.5. Aha. And now we're going to deal with an anisotropic height map. 1.75. Okay, cool. Check. For 0? Cool, that's what I wanted. Okay, so now it's still the same height map, still the same data density, still the same number of faces, still the same heights even, but the X spacing, the Y spacing are all out of whack. Let's run the export function again and see what happens. All right. So, let's window. Heights are correct. This changed. So here, what I'm printing out is the number of faces in X, number of faces in Y, but here is the X expression of the spacing, which I believe was like 1.5. This should be 1.5 times 65536. And this is half-ish. Is that half? Yeah, that's half of 65536. At least it should be. Well, I'll figure it out later. Anyway, so that got exported. Oh! Happy Easter. He is risen. Only in Florida, though. Jesus is taking his time to get his way out to the southwest. Shoot, where's HXD? HXD! Okay, let's go back to this. First 4 bytes. Same data. Number of X faces, number of Y faces, number of textures, and blank. Now, let's look at the big endian expression of this. This is 98304. Calculator. 98304 divided by 65536. 1.5. Cool. That is the X spacing that I was expecting. I mean, obviously this has to be half. 5, 5, 3, 6. There, half. Right. So now the data structure is correctly handling the spacing, and outputting it to a file that is essentially just a pure binary of what we're going to want to load on the Saturn. Unfortunately, guys, I will not be able to get to the Saturn tonight, but let's give it a good solid go of what we expect to be able to write. 7, weren't you supposed to like send me a snippet of something? Well, we'll figure out the ugly way of doing it, which is again, I have to be very careful of how I grab these guys. So the double check. Lights. Screw it up. Figure it out. We are not eating 5 67-cent McDonald's cheeseburgers. I do not have the youth or health to be able to do that. Vert heights. These are fixed point. So what we're gonna want to do, you know, just for safety's sake, I'm gonna move this camera over. It's being annoying for me to look at like that. You? All right. What's the camera see? Uh-oh. Blender! Blender! Rat! Blender, why? Yeah, let me solo Heart Disease in the next FromSoft game. Blender, you're making me cry. Okay. Try this again. Right. Over here. Okay. And I had moved this camera over and saved. And that cost me having to restart Blender. All right. Well, fine. All right, so we're going to take each entry individually and size it or write it out as a fixed point, 4 bytes big endian. So we're going to want to for loop over the verts are n+1, so we got to loop over n+1. There's a for loop where you did that, so I can just copy it over. I know. I have to. All right, you're making me do it. In range. J in I. And we're gonna take the self dot verts, right? Vert height. Vert. Where are you? Oh, so that's correct. Okay. Self dot verts. Where was I? Over here. I index for X. J index for Y. Dot 2 bytes. Big endian. All right. Here. And then we want file write. So we're essentially writing 1 byte at the time. It's probably not the best way of doing it. 7. I swear I will buy you a mic. I mean, not like an XLR like full setup or anything. I will get you a decent, like, maybe not a Blue Yeti or a Snow. I'll find you something. Okay, I will buy you a mic. If I come back out to Oregon, I will buy you a mic. We will go shopping. We'll go to a Best Buy. I'll put it on my account so I can get the points. So the thing about Blend, like, I don't know what it is about audiovisual stuff, but like even the open source stuff, it's all finicky. I haven't even been able to find like an open source video editor. Like I've been having to like go to like whatever free trial of Vegas or whatever is out there to be able to do stuff. Like I don't know about a open source video editor at all, and Blender is my go-to for 3D stuff. But both of those things crash constantly. Even Adobe Premiere will crash constantly. I don't know what it is about these softwares, but just like they're just constantly hanging up. And I'm pretty sure Blender is all like Python on the back end, and they're not going to rewrite that in like a compiled language anytime soon. So I don't know if that's part of the issue. Is like it's just the interpreted languages are hanging up on some load thing or something like that. I don't know. Anyway, we are writing vert heights. Again, vertices, there's one more of them, so we do a +1 on that. And while we're here, let's go ahead and do the quads. Yeah. And just for safety's sake, I'm just going to Bites. Bites. Are you bytes? There, yeah. So I should be able to just run bytes on a single byte of data without. I mean, how cheap is cheap? Also, what? Like I saw your laptop. It didn't look like a crap top. It wasn't like Ramey's like Eastern European like, Soviet era, crap top or anything like that. So it's got a. I think you just need a decent mic. We'll fix it. We'll figure something out. I'll bring mine. I'll bring my Samsung. That's a pretty decent portable mic, and we'll see if that fixes your problem. If so, I'll just let you have that one, and I'll buy it again if I ever need it. Am I doing this right? Okay, let's find out if I'm doing it right. Okay. Alt S to save. All right. Control S to save the whole file. All right. I'm gonna have to run the script again, and here's my favorite part about this whole setup: is when I run the script, I add a new entry. So now, here, I'll do it again because there's only one right now. I'll add a new entry. Now there's 2 entries, and while the system console says, "Hey, we unregister the previous one," and in the unregister function, I thought I had removed the previous menu function before you can unregister the whole thing. Apparently, it doesn't do that. So that's just there. And eventually you get to the point where you got like these things are going off the screen and you got to reset. So what you do is you go up to over here under System, little Blender icon, System, and you reload scripts. And eeny, meeny, miny, come on, let's go. Blender, you're not allowed to crash right now. Come on. I'm trying to demonstrate something. No. It's not, because the main function is only supposed to run when I add the script. If I unregister the, I could try doing that, and what's going to do, it's going to throw an error, because I tried that before. But essentially, main function is only supposed to run the script, and Blender is crashed. Pain in my... Alright. One more for Jesus. Height map. Reload the script just for safety's sake. Okay. Again, object is not there. We're going to run it. It is there. We're going to run it again because we just made an update of some kind. It's there again. We go to the Blender icon. System. Reload scripts. Do not crash. Thank you. Go to object. It's gone. So you saw there was only 2 there. Earlier I had like a dozen or 2 dozen. So, kind of had to do that. Anyway. Add that back in and run the object thing again. Okay. Export height map. Now, what's HXD look like? Boom! All right. Let's try to parse through all this. Here's one axis. Here's the other axis. Wait, am I 4-byte aligned? 1, 3. Is HXD? No. Oh, here it is. Okay. Here's the start of my index, my vertex index data. So, no, not my vertex. What's the first thing that gets saved in the right file? It's the quads, the vert height. Oh, it's the vert heights. Oh, okay, yeah, that is the start of my vertex height data. So we have a 0, 3 more zeros, and then 2 more zeros. right? Bytes. More zeros. A few more zeros. Okay. I can count. 1, 2, 3. 6. Okay. Here's the first one. And then we should have 5 ones in a row. 1, 2, 3, 4, 5, 6 runs in a row? Do I know how to count? Let's go over the console and just double check and make sure I know how to count. Okay. Not you, you. There we go. A whole bunch of zeros, and then yes, that's 9 zeros in a row, and then 1, 2, 3, 4, 5, 6 ones. Okay, 6 ones in a row. So that's let's double check, make sure I know how to count. 1, 2, 3, 4, 5, 6 ones in a row. Is it telling me how many bytes I have highlighted? 18. That sounds wrong. No, this is not 18. This is 16 plus 8. Oh, this is in hex. Okay, I'm done. I'm not 2 bytes off. It's not 2 bytes off. No. So I'll tell you. So we have. Let's go over the first row. The first row should be 8 vertex entries. That's 8 zeros. So that starts over here. Here's one of them. And then here's 4 more. That's 5. 6, 7, 1, 2, 4, 8. Okay, that's the 8 zeros from the first row. The second row has a 0 to start. That's this guy right over here. Then we have 6 ones in a row. 1, 2, 3, 4, 5, 6, and then a 0 to end it. All right, that brings us over here. We got a 0 to start the next one, and then we should have 1, 3, 3, 3, 2.5, 2. Or, sorry, 1. 1, 3, 3, 3, 2.5, 1. Let's see that. 0. Okay, then we have 1, 3, 3, 3, 3. Wait. Am I going crazy? 1, 3, 3, 3, 3, 1, 0. Am I missing something? 1, 3, 3, 3. The last one should have been 2.5. Oh, I think I know what happened. I think there's a rounding error of some kind. I think it's dropping something. So that's a problem. Let's bug check this real quick by intentionally putting one of my heights. Make it much easier to find. So this guy, we're gonna raise him up to 0.25 or 0.75. It should be pretty easy to find 0.75. That should be 2 ones in a row. All right. At least by my reckoning. Board height map. Blender. Oh, you were getting. Really? Is it because of OBS? Is it because I have OBS open? Is that why? Noxious. Okay. Try again. Raising this guy up to 0.75. All right. Now, let us export the height map. We'll look for... That's correct. That is what we expect to see, right? That's the first number. 49152. 49152. 1, 1, 1, 1, 1, and then 0, and then 0, and then 1, 3, 3, 3, 3, 1, 0. Why is the third one 3? It's not supposed to be 3. It's supposed to be 3. Less than 3. Oh! Oh no, I'm dumb. I'm done. I should have. No, wait. I'm not that dumb. I am this dumb. Am I this dumb? 199. Jeez. Okay. Where? Okay. 163840. Let's Is there a way to make HXC interpret things as 4 bytes at a time? Byte size. 4 bytes at a time. Okay. So here's the first 4 bytes. We are 4 byte. Okay, no, this is the first 4 bytes. Okay. And then that number, and then 1. Okay, these are the first 2 numbers. 000. Wait a minute. I think I misinterpreted. That's already 1.5. No, that's 1/2. 4915. Okay, here's the first number. That's 1.5. That's the X size. This is the Y size. Here's the start of the actual data. 49152. That is the first thing that I put in. That's the 0.75 that I put in. We are looking for a 2.5. We're looking for a 163840. So one of these guys should look like 163840. Here's 196608. Okay. 196608. 196608. 196608. 1. 65536. We have 1, 2, 3, 4. 966. 196608 in a row. What is going on with this index right here? 5 TAC 2. What happened? Five TAC 2. Okay, so I don't think the big endian part is right. I think the verts right itself is the problem. So let's go over here. Whole plus decimal. Here's the whole number. That's the floor of the coordinate itself. So this is a floating point number. It's going to floor it down. In this case, that should give us 2. All right, that's the whole number is 2. And then the partial should give us 65536 times the partial, so half of that. And that results in this right over here when we print this all out. So this looks correct. The whole plus the decimal divided by the correct number there. Wait a minute. Just for my own sake, let us print the whole itself. Whole as a whole. Save. Come on. I should just edit this in Notepad++ or something on the side and just Thing is, Blender's got stupid memory things, so... For some reason, that specific entry does not seem to be right. Because it should be over here. Right? We should have, Been? On? Let us, add in that extra print statement. Oh, I already added it. It's already saved. We can run it. Down here. Open up the system console. Okay. So, was it 2-Tac-5 or 5-Tac-2? Wait a minute. Oh, I see what happened here. We're going in a different order. Oh, geez, I feel so stupid. Okay, we didn't have to do any of this crap. Okay, I'll show you what happened. We're going up. We're going up on, along the columns, right? We're going up vertically, so we're staying at y equals 0 and just going x all the way through. Wait a minute, isn't that what we're doing? But when we write the data structure, I need to reverse the order of the data structure right. That's the problem, because that's not what I'm expecting. Okay, you see how I'm going through x as the top level, y as the bottom level? That means that I am iterating through y first before iterating through x. But what I really want to do is iterate through y on the top level. So iterate through the x first on the lowest level before doing the y. That's why it's in a different order, because I'm not reading the row I thought I'm reading a column. So it's saving in a different order. I think I caught that. First actual mistake from before stream. Come on. Blender. It's like the longer the stream is, the more Blender crashes on me, and I do not have a weak computer. Okay. Double check. Right did not save. No, wait, that's the old. Let's see if the new Python saved. Right. YX. Okay, YX. Okay, so this is why we unlink and reopen, because it had a bad thing in its memory and the actual write was still correct, because I already saved it. So we need to iterate through X first before we start iterating Y, because I was going in the wrong order. Let's try this again. Run the script. That'll add it to the object list. Then we can export the height map. And now HXD should show us what we expect to see, which is 16.384.840. Exactly what we expected, exactly the location we expected. So we find 3 3s, a 2.5, and a 1, and then a 0, and that's that row. Next row starts. Nope. I probably can get rid of that extra print color because that makes it hard to read. There's these. 1 looks like 2.5. Or sorry, no, it says right here. 1, 3, 2, 2, 2.5, 1, 0. So that's the next thing we expect to see. So 1, 3, 2, 2, 2.5, 1, 0. All right. So let's just get these side by side so we can just double check. Okay. 1, 3, 2, 2, 2.5, 1, 0. Okay, we just did that? Or is that the same thing? Check. 1, 3, 2, 2, 2.5, 1, 0. Okay, yeah, no, that was the start of the new one. We should be on... Okay, this one. 1, 3, 3, 3, 2.5, 1, 0. 0, 1, 3, 3, 3, 2.5, 1, 0. Okay, next one. 1, 1, 1, just a bunch of ones. 1, 1, 1, 1, 1, 1. Okay, now here's the start of the index. That's not good. The index is not saving. Which doesn't look like it is. Okay, now we got a problem. So when I went to go save the texture indices per face, and these guys are actually supposed to be 8-bit aligned. Or not, I mean, aligned is a weak way of saying it. Basically, they're all supposed to be a byte each. I'm not seeing it. So, what happened? Verts? So, bytes applied to that didn't seem to work, but the verts... Verts. Oh! No. I'm dumb. Quads. We're going through quads. Oopsie whoopsie. Try again. Export height map. HXD. Tell me what I want to see. There be more to this? Be a lot more to this. Did we get an error of some kind? Okay, here's what I'm gonna do. I'm gonna wipe the height map and out of this. Okay, and let's try this again. Okay. Quads should go to bytes, but the verts should have already been written out as big end. We should have gotten a lot of data from the verts. So this is saved. Let me wipe the scripts previously and let Blender crash anyway. Oh! Oh, you didn't crash. Okay, that's nice. Add the script. Export the height map. Okay. That'll get us a new height map file. Drop a fresh one into here. And it's still short. It feels short. 3, 3. Can I just not count? 0. Okay. 0, 1, 1, 1, 1, 0. Okay. 0. Oh, the 0 starts at 8. 0. Okay, here's the start of the data, and it's 1 byte apiece. So now we can start comparing. Maybe I was just psyching myself out. Let's go through the texture index tables. How many zeros do we expect? 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros before we get a 1. Let's see if that's true. 1, 2, 3, 4, 5, 6, 7, 8. Nothing over here. Nothing through any of this. How many bytes do we have? Math. Okay. 5 times 16 plus 2. 82. It's 82. 9 times 9 plus 1. Amazing. Geez. Okay, let's try this again. These are quads. Let's do a little printy print here. And see if there's a way to make this. I need to do one of these. And we can get rid of this here too. We got the information we need from that. Why is there no horizontal scroll bar? Okay. So let us do this dot 2 underscore bytes and see if that helps. And we're going to do another version of this where it's just bytes applied to value. And we'll see which one of it likes better. Either. Save. Blender. Blender. I'm surprised I lasted this long without crashing out. Either do the caffeine or do the frustration from Blender. Alright. Tell me what I want to see. Okay, we had an additional couple print statements upstream of the actual write, because the write is not doing what we think it should be doing. And instead of one, okay, let's geez, what was it at? Let's just do 1, 1. That should be this guy up here. It should give us the number 1. Actually, let's do 2, 2, and that should give us 5. We really know what's going on. Okay, save. Rid of the extra prints in here too. Add function, export the height map. Right, and let's put up the some console. Okay. The first one gives 5. The second one gives a whole bunch of zeros. Interesting. Well, it appears we have a winner. It's not bytes, it's 2 bytes. Because Python bytes. Alright. Add again. Gotta be kidding me, Blender. You've been open for 2 seconds. Hey, okay. One more for Jesus, and then we're calling it a night. Last nerve. My actual last nerve. Alright. 2 bytes. We established that's what we probably want to see. This has been saved correctly already, so we will run the script to add it to the object. Export the height map. Now under HXD, we should starting from one of these lines. Okay, probably starting from here. I'm going to say here. Makes sense to me. Okay, I'll count properly. Okay, the last row should be here, so there should be 8 faces. 7 faces. 7 faces. 1, 5, 6, 7, giving us 8, 9, 10, 11, 12. Okay, you know what? I probably don't know count tonight. All right. So we should have 1, 2, 3, 4, 5, 6, 7, 8 zeros to terminate our height data. 1, 2, 3, 4, 5, 6, 7, 8 zeros. That should be the end of our height data. Then we start 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I got this back. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros to terminate our height data. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then we get to the start of our... I need to reverse these colors. I just... Obnoxious. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So that should be 4 over here, 4 over here, and then 1, 1, 1, 1, 1, 5 ones. 1, 2, 3, 4, 5, and then 2 zeros. 2 zeros. And then, okay, 1, 5, 6, 7, 1. 1, 5, 6, 7, 1. 0, 0. 0? 1, 3, 3, 4, 1, 0, 0. 0. 1, 3, 3, 4, 1, 0, 0. Okay. 1, 2, 2, 2, 1, 0, 0. 1, 2, 2, 2, 1, 0, 0. 1, 2, 2, 2. Okay, okay, this is the part where I know I need to end stream. 1, 1, 1, 1, 1, and then a bunch of zeros. So let's get 1, 2, 3, 4, 5 ones. And then how many zeros? 1, 2, 3, 4, 5, 6, 7, 8 zeros. And how many zeros is this? 1, 2, 3, 4, 5, 6, 7, 8. All right. That is where I am calling it. As far as the script has been designed to function, it is functioning correctly. We have the number of faces in the X direction, the number of faces in the Y direction. No, I am not going to recreate a new map just to test to see if those things are different. I'm confident they're working, and I don't feel like making a new height map right now. I'll do that next time. 8 textures, 0 through 7. Blank data. And then we have a whole bunch of height map data. And you know what? What I'll do, I'll just go over here, and I'll just transpose map height with textures. Okay. I'll just transpose them. Here, this goes here now. Thank you. All right. And let me just double check to make sure that's going to run correct. Blender. No. I only said one more for Jesus. Okay. And half the clips from the stream is just going to be me yelling at Blender. Who am I kidding? No one's going to clip this crap. Let's try one last Blender opening before we call it a night. All right. Close. Yes, delete. Open. Correct one. All right. Calculate is going to go through height first, then textures, then write the file. So the console log, or that's not console? Yeah, console log. So the console log will reflect what we expect to see. All right. So the first thing we get is all the height data in fixed point structure. So that's all 4 bytes a piece, 32 bits. And we get to the end of these, and then we start getting at these, and these are just single byte texture indices, which again, we've just verified is working great. Thing writes a new file every time, which is kind of what you want Exporter to do. The data structure seems to be checking out so far. The only thing missing is I need to actually be able to extract the texture data. Now, this is the point at which I say it is 10:40 on a Saturday night, and I could be playing my Steam Deck right now because I'm not getting to sleep with 160 milligrams of caffeine still in my blood. What I need to do is I need to intelligently be able to go inside of each one of these faces, go into the material, and assuming that there was an image here, grab the image, sample it at, let's call it 32 by 32 or whatever the size of the image is. Something that's 8 pixel line because VDP1 is special like that. And then not only get that, write that texture file, but then subdivide the texture. So let me open up Paint, and I probably already have something, but I'll redraw it again. We're going to have a texture. We're going to call it 32 by 32. We're going to have, that texture is going to have 4 quarters to it. Really? Right? Now, when you load the texture the first time, let me finish drawing out these quarters. I don't know if I accidentally made like the Windows logo or something, but if I did, I'm sorry. I apologize. And I'm going to go in order of how we write the data. You know what? I should have drawn it like that to illustrate what I'm talking about. Okay. And yellow. All right. I need to do what Primeagen does and have like a black background where it's like MS Paint or whatever paint program he uses, probably Linux based, but black background with white marker on top. So I stopped flashbanging you guys with Microsoft's terrible color sense. Anyway, when you write a texture into VRAM, you're going from left to right, from I believe bottom to top, but let's just call it top to bottom just for visual sake. Right, so you're going through one line at a time, one at a time. Notice when I go through and I raster over the image, I'm going over the first quarter and the second quarter before I go back to the first quarter. If I want to subdivide, I need to take the data from just this quarter and turn it into its own image, so I just raster over it, and that's the data I'm going to send to VDP1 as a draw call. And then I go over and do the second quarter, then the third quarter, right? Then the fourth quarter. And that's representative of me going through like this, when in reality, for the major texture, I'm going like this. And if that doesn't make sense to you, I am sorry, but I don't have time to explain it better, but I will next time on the stream if there calls for it. John, you've caught me at the end of the stream, so thank you for joining for as long as you did. Thank you again to, was it Peru for the raid? Yeah, Peru. Peru, thank you for the raid. I'm surprised to see everyone is still here after me just seeing Blender crash over and over again. The plan is for once I figure out this texture export thing, we will have one single file that's optimized to load into the Saturn. Where you take the first X chunks of it and load that into high work RAM as just our map data, and the rest of it can just go in as texture data to VRAM. Well, I try my best. So I appreciate your appreciation. Yeah. Once again, before I close upstream, I want to remind everyone a couple things. One, the showcase still has, I believe what we said, 6 Mondays until deadline, May 11th. So there's plenty of time for you guys to learn SRL or Joe Engine or whatever you want, even y'all if you are feeling masochistic, and just figuring out how to make a Saturn game, submitting it via this entry form on emeraldnova.com, which links to a Google form entry thing, and upload it to the Sega Extreme thread. Everyone should be a member of Sega Extreme. I'm not logged in here. I don't know why, but I should be. But everyone should be a member of Sega Extreme. I post, showcase entry updates. I post Game of the Month articles, of which I owe another one, so I got to write one this weekend. And it's just a great bit of fun, and that's where the whole community is. That's where all the Saturn developers are. Alongside that, if you don't feel like you have time to try to make your own game, and I promise you, if you just put in some time over the weekends, you can find time to make something simple. If you want to donate to the competition for the prize pool for the 6 categories that will be awarded by our panel of judges, plus Cerbero, who needs to be added to this judge panel, click this donate link, takes you to PayPal. All the money from this PayPal only goes to, I need to rename that to Showcase, goes to the prize pool, does not go to me. So please donate if you have the money to donate. If not, please, I prefer you make a game. If you can't make a game, I ask that you consider donating to the prize pool. Anyway, that's it for the day. Thank you all for joining me as Blender took a small part of my soul. And I will hopefully be back sometime in the middle of the week to work on Galaxmus, because I owe Daniel Fredrickson that. I was planning on streaming it tonight, but I had this in my head and I couldn't let it go until I got to basically this point. So thank you guys for joining me for that. I'm thinking maybe Tuesday, maybe Wednesday, I will try to stream Galaxmus, which is kind of like, think of like Star Fox, but Christmas themed, and with Daniel Fredrickson as the starring role of Santa. So, look forward to that. I'm not going to promise Tuesday, but I'm thinking Tuesday. So, guys, come back around the same bat time to channel. 9 p.m. Berkey time, which is, and I wrote this down on Blue Sky. I skeeted it earlier on Blue Sky. Let me see what that is in see. Jeez. Notification. 3 a.m. UTC. There we go. So 3 a.m. for the Brits. Never been too friendly to the Eurozoners for the stream. So join me Tuesday around 3 a.m. UTC, 9 p.m. Mountain Time, and I will hopefully be working on an actual Saturn game. Not connected to this hype map, but I will continue to work on this hype map on the side, and if I find more inspiration, if I figure out, probably with 7 Shades' help, how to map those textures, I will be back to demonstrate how it works after I made a little bit of headway offline. Thank you everyone for joining me. I'm closing up stream for now. Appreciate everyone for coming in. Good night, everyone.